Assalamualaikum and selamat sejahtera. We are the Polytechnic Muazzam Shah student and our project is monitoring and control-based automation system parameters using IoT. Our group member include me, Muhammad Imran bin Jasman, 19 DMA 19 F1016.
Next, Muhammad Zulaiman bin Badu Isham, 19 DNA 19 F1005.
And for the final member of our group is Xavier Chang, 19 DMA 19 F1027.
Introduction to our project. Data monitoring and data logging is one of the important features that any industrial machines are expected to possess in recent times. It helps the industrialists to improve productivity. New industrial machines usually have built-in devices that connected to the internet and can be monitored directly. But older machines don't have that features. This motivates us to work towards upgrading the older machine like the small-scale automation station to have the ability to send data and be controlled via internet. Figure 1 shows the old automation machine that cannot connect to the internet. Figure 2 shows new industrial machines that have built-in devices that connect to the internet. Our objective is to take remote monitoring and controlling action. Number 2 is to prepare a user manual. And lastly, number 3, to develop a PLC program to move the system. The problem statement for our project is the mini-scale automation station has not been in operation for a long time during the PMP session. Machine can still be used and are useful for study material. This machine has not been used for a long time because it was obsolete. Many new machines can be controlled or the use of the internet network. By using IoT, the machine can be upgraded and be reused. The scope of our research. For our research in this experiment, this IoT implementation may help ease the work in automation industry and extend the innovation and invention in the engineering society. Project statement for our project. The Internet of Things, IoT, has not been around for a very long. There have been visions of machines communicating with one another since the early 1800s. By the year of 2013, the Internet of Things had evolved into a system using multiple technologies. The traditional field of automation, wireless sensor network, GPS control system, and others all support the IoT. Figure 1.2.1 shows the first telegraph developed in 1840, described as wireless telegraphy. And now, Zul will continue our presentation.
Project impact for our project. All automation machines can be modernized and be used. Engineer can monitor the data and control the machine activities from a great distance. Help save costs from buying a new automation machine that comes with the Wi-Fi based monitor system. Is the user to set a new program to the automation machine through internet. So for the next slide is estimate cost. For our project, we buy 3 components. For the first component, we have V-box. The quantity is 1 of the price of 650 ringgit. For the second item, we have micro PLC. The quantity is 1 at the price 121 ringgit and 80 cents. For the third component, we have power supply. The quantity is 1 at the price 46 ringgit. Lastly, for our total cost is 817 ringgit and 80 cents. Next, small-scale automation station for our project. We have 4 parts. So, for the first part is gripper. which will open and close when picking up the pellets. For the second part is solenoid 5 3-way and 5 2-way. This solenoid will control all the cylinder airflow by either a law or prevents airflow through valve. For the third part is double-acting cylinder, which will go up and down. For the last part is rotary cylinder, which will go left and right. Next material used for our project. The first material, air compressor, for the automation system to move. The second material is mini PLC. We will be programming for the automation station. The third material is power supply, which comes 24 volts. The last material is Vicon VBox. This is the server that we needed for us to IoT the small scale automation station. Next, I will pass to my friend Xavier.
This is the angle taken, picture taken from upper angle and the front angle for our small scale automation station. This is when the robotic arm turn left, and the right side of the picture is when the robotic arm turn right. The small-scale automation station were connected with Mitsubishi FX1N mini PLC, in which we use Mitsubishi GX work to program it. The PLC that have fitted with RS232 adapter were then connected to the VBox. With the VBox then were connected through micro USB cable to the laptop. This is to program the PLC. Using Vicon VBox application, we insert the needed command for the VBox to send the data to the PLC. From here on, we can monitor and control the automation system by using the Vicon application available in both laptop and smartphone. This is the movement for our automation station. So the first step is the robot turn left and ready to down for 5 seconds. The sensor status for this movement is solenoid 1 will open and solenoid 5 and 3 will open, while solenoid 2 and 4 will close. The second step is robot down and ready to open gripper for 5 seconds. Solenoid sensor 1, 2, 4 will off. Meanwhile, sensor 3 and 5 will open up. Sensor 3, step 3, the gripper goes down, the gripper close and to pick pellet for 1 second. Sensor 1, sensor 2 and sensor 4 will close, while sensor 3 and only sensor 3 is open. For step 4, the robot will go up for 3 seconds. Sensor 1, sensor 3 and sensor 5 will open up, while sensor 2 and sensor 4 will close. The next step is step 5, which the robot will turn right for 5 seconds. Sensor 1 and sensor 2 will open up, while sensor 3, 4 and 5 will be closed. The sixth step is the robot will go down for 3 seconds. Sensor 1 will be closed, sensor 2 will be open, sensor 3, 4 and 5 will be closed. The seventh step is the gripper will open up for 2 seconds. Sensor 1 will be closed, sensor 2 will be open, sensor 3, 4 will be closed and sensor 5 will be open. For our 8th step, the robot will go up for 3 seconds. Sensor 1, 2 and 5 will be open, sensor 3 and 4 will close. In our 9th step, the robot will turn right. Sensor 1, 2, and 5 will open, and sensor 3 and 4 will be closed. So this is our ladder diagram for our PLC. X6 is the push start button for our supply power. X5 is the start button for our PLC to move its logic control. So M1 is the internal relay, the first internal relay. It will activate a timer, which is 5 seconds, to activate rotary cylinder left. And then the next step is rotary cylinder left will on a timer to make the cylinder go down. And then the next step is after the cylinder goes down, the gripper will pick the pallet and close up the gripper. The next step is the cylinder will go up for 5 seconds, and the next is the cylinder will rotate to right for 5 seconds. After that, timer will start count for the cylinder to go down and drop the pallet. After that, it will go up and return to its original position. M2 is for the sequence to stop. Next, this is the command for our VBox. As you can see, next, we will show our video for our demonstration in the small scale automation PLC. That is all for our presentation. Thank you.
Thank you.
Thank you.